Hi everyone, today we are going to be looking at exponential functions. This is our last unit of e-learning in the school year. We're going to compare it a little bit to what we've done in the past so that you can kind of see the differences. And then we're going to conclude today by trying to see if we can actually evaluate in our calculator because sometimes they can get a little bit messy. So what is an exponential function? Let's first look at what maybe a linear function is. So a linear function, that was something like y equals 3x plus 1 or something, okay? Our highest exponent for x was just 1. Versus then we went into quadratics. And so a quadratic function had a highest exponent of 2, maybe 2x squared minus 4, something like that. So our exponents were 1 or 2. An exponential function, what makes it different is that instead we're going to have the x in the exponent. Okay, so if x is the exponent, it's not in line with everything else. It is actually the exponent. That's what makes it exponential. Okay, so that's what you're looking for. When you see x in the exponent, it is now called an exponential function. And so we're going to just maybe do a rough example or two to kind of get the hang of what that is. Let's say that you bought an iPhone, and your iPhone, when you bought it, was $1,200. But every year, because they keep coming up with new iPhones, the value of the phone goes down by 50%. So if it was $1,200 new, how much is it a year later? Losing 50% of its value would mean it's going to go down to $600. And then the next year, it's going to go down to only $300. If you try to sell it the next year, you can maybe get $150, right? So this continues to go on and on. So the amount that it's changing is not consistent. A linear function, it changes by the same amount every time. But if we look at the difference here, that's a difference of $600 versus the difference here is only $75. So that's what makes it exponential. The amount that we're changing is not consistent. But what we do see is a pattern. It's being reduced by half every time. Now, it doesn't have to be reduced by half. We could be making a function that is growing or decreasing. This is one that happens to be decreasing. If we look at what this would look like on a graph, if we were to plot some points here on an XY axis, we started really high, all the way up at 1,200. Okay, and then it went all the way down to 600, and then it was down to 300, 150, 75. If we kept going with that, half of 75, we're starting to get into some decimals. We're somewhere around 30 something, and then half of that, maybe it's only worth $15. I don't know, this would be maybe way in the future. But if you keep taking half of 15, half of 7.5, half of that, are you ever going to get into a negative value of your phone? No, and that's what's interesting about exponential functions is you're not going to get into negative numbers typically unless the graph had some sort of weird conditions. But for most of the graphs we're going to be looking at, we can continue to get closer and closer to zero. Maybe our phone might only be worth pennies way in the future. Maybe its value would actually start going up and then it wouldn't be exponential anymore. But we're just going to be hovering along zero. Okay, so the graphs are they have drastic change and then they start to kind of level out. So this would be an exponential function that would be a decreasing one. Just want you to get an idea. We're not going to do too much graphing because that's kind of hard in e-learning, but we want you to be able to visualize it. And then we also could have a growing exponential function. This would be potentially modeled by the virus, right? So we started with just a small amount of people getting the virus, but then those small amount of people they each spread it to 3 people. And then all of those people, then they each spread it to 3 people. So our amount of people went up very fast. So our curve might look something like that. That would be an increasing exponential function where we were close to zero originally, and then it shoots up really quickly. So that's an example of a graph. Let's go ahead and start maybe just trying to evaluate. I don't want to keep this lesson pretty short. So some of our equations might be kind of complex. We might have one that says you put in, let's say, $1,000 into a bank account, and that bank account is earning you money. So it's taking the 100% that you put in, and it's adding, let's say, 5% 4 times a year. And we have this function, okay? So kind of messy, but we just want to practice evaluating. Evaluate, let's say evaluate after, how long do we want to look at? Let's say 10 years. So when x equals 10, what I'm going to have us do is we're going to try putting x equals 10 right here. What is that going to make our exponent now? You can multiply that. That is the only thing I'd probably do in my head. Maybe is multiply what those are. So we're going to have an exponent of 40, and we're just going to try to type this in to find out what would our y value be, or what would our ending amount be. So I'm going to use my graphing calculator. If you don't have a calculator at home with you, let us know, because there are different websites that have kind of simulators that you could be using instead. So I'm going to try to get this close to the screen and see if you can see it. Okay, so what we're going to be typing in is that 1,000. Let me get that equation there. So 1,000, and type it just like we see, parentheses. And then you see it was 1 plus, so we're going to type 1 plus, and that 0.05 divided by 4, end parentheses. Now we don't have to worry about order of operations, because the calculator knows PEMDAS, and it's going to do that dividing before it adds to the 1, because that's just our order of operations. And then for our exponent, we're going to find this button right here. Mine's above the division sign. It's a little up arrow. That is telling us go up into the exponent. Now mine, on my calculator, it actually went up, like it raised it higher, but that doesn't happen for everyone. So if your calculator doesn't raise up, that's where I'm going to have you multiply those together right away, or you could use parentheses, because it might get a little bit confusing. I'm going to go ahead and just type in 40. 4 times x, when x is 10, would have been 40. And then we're just going to press enter, okay? So notice I have it just the same way that it was written on the board. We have it in our calculator, and we're going to find out that our $1,000 went up to 1643. 1643. 62. Okay, so we're going to give you some practice for you to do, just to make sure you get the hang of that, whether it's on your calculator or an online website that helps evaluate. Maybe Desmos might be a good one, but let us know if you're having any trouble. All right, thanks everyone.